This tutorial will provide an introduction to Zstash, which is a HPSS long-term archiving solution for E3SM. First, we'll go over some terminology. The Zstash archive is a set of files that will include the index.db, which is a SQLite database, as well as tar files, which are numbered beginning with 000,000. HPSS is a long-term tape storage system. We'll use the phrase HPSS archive for the Zstash archive that exists on HPSS, and we'll use local archive or cache for the Zstash archive on our local file system. The default name for this is Zstash. We'll use the phrase source directory for the directory whose contents we are archiving. Zstash has several commands available. The first we'll cover is create, which creates a new cache or local archive, creates the tar file of the source directory's contents, and if you're using HPSS, it will store it to the HPSS archive. Check verifies files were uploaded on HPSS successfully. Update adds new or modified files to an existing Zstash archive, ignoring the unmodified files. Extract extracts files from an existing Zstash archive into the current directory. List views files in the existing Zstash archive, and version will show you the version number. Each of these commands has several options available. This table will show you all the options available for each individual command. We will now install the Zstash environment. We'll do that by installing the E3SM unified environment, which includes Zstash, with this command. You can see that we're now in the E3SM unified environment. We'll do a few steps now to ease the transition between examples. We'll start by changing our directory to a good workspace. On Cori, we can use cscratch. We will make a tutorial directory and change into that directory. We'll then want to create a setup script that we can run at the beginning of each of the examples. This setup script will create the directory structure outlined in the commented section. We will now create another script to add files later on. We'll call this add files. This script will change the directory structure to match the commented section if run immediately after the script that we just created, the setup.sh script. To run these scripts, we'll need to change their mode. Lastly, we'll switch over to our other window and log into the HSI system. This is HPSS. If you haven't used HPSS before, you will have to log in by entering your credentials. We'll switch back to our other window to begin the first of our examples, the simple case. We'll start by running our setup script. We'll create the local and HPSS Zstash archives with the Zstash create command. We set the HPSS archive to be Zstash archive and the source directory to be Zstash demo. Our local cache can be seen with Zstash demo/Zstash. You can see that it only includes the index.db file. We'll now go to the HPSS window to look at the HPSS archive. You can see that in addition to the index.db file, there is also the tar file created from the source directory. Switching back, we can now add more files with the add file script that we created earlier. We'll then want to change directory into the source directory, which we've called Zstash demo. We want to do this so that we can run the update command. Zstash update will update the archives. We have to specify that we want Zstash archive to be updated on HPSS. If we go back to the HPSS window, we'll see that Zstash archive now includes an extra tar file created from the update. Switching back, we can see that the cache Zstash still only contains the index.db file locally. Next, we will extract the files that we have archived. We will change back into the tutorial directory and make a new directory for extracting into. We will now enter the directory we created to extract into. We will then extract into it with the zstash extract command. Notice that once again we have to specify the HPSS archive. You can see that the contents of Zstash extraction are identical to the contents of Zstash demo. To clean up for the next example, we will change back into the tutorial directory remove the directories we created, and in the HPSS window, we will remove the files we created there. We'll also clear the terminal so that we can start fresh with the next example. We will now do an example without HPSS. First, we'll run our setup script. And then we will run zstash create, but this time with HPSS equals none. Zstash demo/zstash is still our cache, but you'll notice that the tar file is now there. And if we go to HPSS, we have no archives available. That's because HPSS equals none specifies that Zstash should not archive to HPSS. We can now add files with our add file script. We will enter our source directory, and we will update once again with zstash update. Again, we'll have to specify that HPSS is none. Now if we look at our cache, which is zstash, we'll notice that we have an extra tar file from the update. And once again, we have nothing in the HPSS system. We'll change directory to the tutorial directory. We'll create the zstash extraction directory and change into it. This time we'll need to copy over the cache because there is no HPSS archive storing the cache for us to extract from. Now we can extract using HPSS equals none once again. As was the simple case, the contents of zstash extraction and zstash demo will be identical. We will now clean up for the next example. We'll change back to the tutorial directory, and we will remove the directories we created. We have nothing to clean up from HPSS because we have done all our archiving locally. We'll set up our directory structure. This example will be to check file integrity. We'll start by creating the zstash archives exactly as we did with the simple case. We'll change into the zstash demo directory, and this time we'll try a new command, zstash check, which checks file integrity. Notice we have to specify the HPSS archive. You can see that we have no failures detected when checking the files. Our cache Zstash will still only contain index.db. Over on the HPSS side, we'll see that we have the Zstash archive available, which contains the tar file too. Now we will clean up. We'll change back to the tutorial directory. Remove the demo directory. And in the HPSS windows, we will remove the files we created there. We'll now do a Zstash ls example. As usual, we'll start with our setup script. We'll then create a Zstash archive just as we did in the simple case. We'll cd into Zstash demo. And we will run the Zstash list command. If we look at our current directory, we can see that it actually matches the output of Zstash ls, except we have the Zstash cache as well. So Zstash ls is listing the contents of the tar file stored in the HPSS archive that we've labeled Zstash archive. Let's try extracting and doing the list again. We'll change into the tutorial directory. We'll make the Zstash extraction directory. Change into it. And extract from our archive. Now that we've extracted those files, let's try Zstash ls again. We'll change back to Zstash demo. And we'll see if anything has changed with Zstash ls. We can see that nothing has changed. As usual, we will now clean up. We'll change to the tutorial directory. And remove the folders we created. In our HPSS window, we will remove the files that we created. Our last example will be to archive actual E3SM output. We'll create a directory and enter it, and copy over actual data from E3SM. We'll just copy over 2 files to keep the example small. This is our second file we're adding. Now we will SSH into a data transfer node. I've SSH'd into the data transfer node. We'll use screen so if the data takes too long to process, we can detach and reattach. We'll make sure we're running on bash. We will install the E3SM unified environment. We'll cd to our tutorial. And we will create a Zstash archive out of E3SM output. We've now created a Zstash archive with E3SM output data. To clean up, we'll exit this environment and exit the data transfer node. We'll clear up our directory. We will also delete the files on HPSS.